Welcome to today's Whiteboard Wednesday. I am Pushkar Patwardhan, DSP software architect at Cadence, and today we are going to talk about floating point support in Tensilica DSPs. In a previous video, we looked at the application space and the algorithms in each application space which require floating point computations. So today let us look at each of the application spaces and the Tensilica DSPs with floating point support targeted for the application space areas. We will focus on 32-bit floating point, the single precision floating point, though the DSPs that we mentioned here also support double precision, but for today let us focus on this chart on single precision floating point. And when we consider a DSP, we look at a few things in terms of the floating point support. One is the flops per cycle for the 32-bit single precision floating point operations, and here by flops we will count an add or a subtract or a multiply as one flop each. So that is how we count flops. We will look at the vector SIMD width for the 32-bit floating point support on each of the DSPs, and we will look at the number of slots in VLIW DSP, the number of slots which schedule floating point operations. So we will look at each of these things for the DSPs. For mobile and variables, the Extensa controller can be enabled to have an optional floating point support to do 2 flops per cycle with a SIMD of 1, that is, it is a one-way, a scalar machine, and with 1 slot for the floating point operations. Then there is the Fusion F1 DSP, which also does 2 flops, one way, and 1 slot for floating point operations. The difference between Fusion F1 and Extensa is that the Fusion F1 also has extensive fixed point support for 16-bit multiplies and ALU and 32-bit multiplies and ALU, and a SIMD support for the fixed point. But in terms of the floating point support, they have the same capability. For audio and speech in the Hi-Fi family, there is the Hi-Fi 3 and the Hi-Fi 4, both of which have floating point support. Hi-Fi 3 is 4 flops per cycle, Hi-Fi 4 is 8 flops per cycle. It has a SIMD, both of them have SIMDs of 2-way, and 1 slot for the Hi-Fi 3 and 2 slots for the floating point operations for the Hi-Fi 4. For radar and general DSP, the Fusion G3 DSP has floating point support. It can do 16 flops per cycle, a SIMD of 4-way, and it has 2 VLIW slots for scheduling floating point operations. For wireless communications, the BBE family, the BBE16, the BBE32 and the BBE64. So these, in terms of flops per cycle, the BBE16, the 16 flops per cycle, 32 for the BBE32 EP and 64 flops per cycle for the BBE64. The 16 EP is a 4-way machine for 32-bit floating point, the 32 EP is an 8-way, and the 64 is 16-way. And each of these schedule their floating point operations in 2 slots. And for the vision application space, the Vision P5 and the Vision P6 DSPs, both of them do 32 flops per cycle. Both of them are 16-way SIMD for the 32-bit floating point operations, and both of them schedule the floating point operations in one slot. So this is the range of Tensilica DSPs with floating point support and with their capabilities in terms of flops per cycle, their SIMD and VLIW. So with this range of DSPs, different needs for different application spaces in terms of the compute capability is served by the entire family, starting from low to moderate end capabilities to high end floating point capabilities for the wireless communications and vision space. So this was an overview of the family of Tensilica DSPs with floating point support. Thanks for watching. See you next time.